Hello everyone, I am Divyanshu Kumar and today I will be discussing Codeforces Raif Round. Uh, this was a rated round for both Division 1 and 2, and yes, I was at pupil level before taking this contest, yeah. And so yeah, I will be again starting from pupil. That's why you say never leave your practice, okay? Otherwise no, you may again reach pupil level. Yeah, but it will be a nice road. Let's enjoy. Okay, so let's see. The first problem was very easy. It was given like the rabbit should be able to pull the boxes to the desired place from x1 comma y1 to x2 comma y2, and in one pull he can only move to a distance of 1 unit either towards x or towards y, right? So basically that was the required case, and the rabbit can move, right? Without even moving the box as well. Suppose like if he wants to move to the top one, or if let's say he was going in this direction and he has to change its direction to the top or below, right? Then basically he will need two more moves, right? Because like firstly he will be going one step down and then one step to its left, right, to reach this position from where this rabbit can pull the box downwards, right? So this was an easy question, just like only catch was whether it needs to change direction, then it will need an additional of two moves, right? So the code was pretty simple as well. So basically just take the absolute difference of both the coordinates x1 comma y1 and x2 comma y2 and just add 2 if they both of them are on a different coordinate. So basically if suppose the initial is 2 comma 2 and I have to go to 2 comma 3 only, then basically then I will not need to change my direction. I can just pull in it one direction and be happy about it. Okay, so this just case checks like whether he needs to change direction or not. Okay, and the second one, this was a pretty interesting question. Okay, interesting because like I did miss a few corner cases here and I did make a few wrong submissions in this. So I guess you might have done it in very less number of moves, right? So let's see. So basically in this question, we were given that we have some belted rooms, like these rooms are numbered from 0 to n minus 1. So here, if the number of rooms were 4, so then we have 0, 1, 2, 3. And then there are belts connecting each of the consecutive rooms. And if the belt has a sign of minus, basically the belt is stopped, the snake can go in either direction, towards the first room or back to the 0th room. Similarly, if the belt is clockwise direction, then the snake can only move in the clockwise direction. Or else if it is in the counterclockwise direction, then the snake can only move in the counterclockwise direction, right? And so in this question, there were two scenarios only, right? The first scenario is when the chain is cyclic. So basically then the snake will be able to reach any other rooms, right, from starting with any other room, right? Uh, so if suppose the snake is here, it can again reach here. So all rooms are returnable. And okay, and we just have to output the total number of returnable rooms and be cautious, right? Here we are asked about returnable rooms. Like if the snake starts from room number 1, the snake should return to room 1 only. Okay, not like whether he can go to other room or not. It's just like whether the snake can return to room 1 or not. Okay, and then the second type of chain we can have is an irregular chain. So basically there will be not a cycle, you cannot complete one full cycle here, right? So for the cyclic case, the simple answer would be n, because all rooms are returnable, so you can just all rooms are returnable. And in the irregular chain, so suppose like this chain is a stopped one, this is a clockwise one, this is an anti-clockwise one. So this room is obviously a not returnable one, because if the snake goes in either of the direction, here it cannot go. So and here also it cannot go. This is an unescapable room, right? So basically this is not a returnable room. Similarly, if it goes here and then again it will get stuck, right? So this is also a not returnable room. And so only thing, if this room is returnable or not, that is, it is because like let's say the snake goes to this room, it can again come back to this room, so this is a returnable room. Similarly this one as well. So basically in an irregular chain, a small observation would be just like if either of the connecting side is -1, means like the belt is off, then that's a returnable room, because the snake can go from the same belt and then return from the same belt, right? So that's why any chain, any room having a stopped chain or belt is our desired answer. Okay, so let's go. But what is the catch here? So detecting full cycles, like see this scenario, is this a full cycle or not? So basically this is a complete cycle, right? And this is the case I missed while coding in my first previous wrong submissions, and then I gain a total of -3, I guess, in this question. So and then plus I did submit in my fourth attempt, right? So I guess that would be a +4, I guess, or something like that. Yeah. So this was pretty miserable for me. Yeah. But I missed this case in the contest time. So basically, like if see uh, if the belt is off, right, then basically it can take any of the forms, right? So if this is in this direction, the snake can return, right? So here also the answer is N, not just the rooms in touch with the zeroth block, right? So basically how you check for the cycle is just like, let's say if you call this belt as 0, right, then basically 0 plus if this or other things are of same sign, right, then basically they form a complete cycle, right? That's all. And for the code, I just wrote one other small optimization, is like either to just avoid one check, like which both are 0 or not, right? So suppose this was the room, right, I had to check like whether this belt is 0 or either of them, right? So I just use integer conversion here, 0 for this one, -1 for this, and 1 for this. So as if I just multiply the adjacent two values, if either of them is 0, I will get a 0 here, right? That's why I use this convention, so as it is easier for me to check. Okay, and then I am just inputting the array, and then I'm just checking if whether they are same or not. If they are same, so basically if same plus 0 is equal to n minus 1, so means basically all the rooms are returnable, it forms a complete cycle. Okay, else just I'm just checking like how many rooms have either of them as a belt 0, like the belt is off, then that's our answer. Okay, and then just outputting that. Okay, let's go to the next question. So this was again a similar very known question. So this was not, I don't know whether it's a very known question or not, but I think so basically in this question the string consists of only A or B, capital B, and then the pilot can drop bombs at a substring AB or BB only, right? So suppose my initial string is AB, AA, BB, AAB, ABBA, right? So basically then the pilot can drop a bomb at AB, AB and AB, right? And then basically he can again drop a bomb at AB. So basically after bombing, the left characters will form the new string, and he can again bomb the string till the string becomes of the smallest strength possible, right? So if he again bombs AB, it will be again A left, and then he cannot do anything to this, right? So answer will be the minimum length which will be left after bombing. So here answer will be 1. Okay, so here the only optimization you need to see is like how you will get the characters after deletion of the this AB. Let me just take a few more examples, or just one more example. So let's say your string is AAB of this form, right? Now by seeing this, obviously I think you might have remembered balancing the brackets, right? So this question is kind of similar to that, right? Only thing is like the B can match with B itself. Now suppose you remove B with suppose you remove firstly this BB and this A, then you will be left with capital AA, right? But that's not the smallest you can get, right? Obviously you can see like you can firstly bomb this AB, right? And then you will be left with this string, then sorry, this one, and then you can just bomb this AB, you will be left with this, and then you can again bomb this AB, and then you will be left with a string of length 0, right? So the only greedy approach you need to apply is when you are trying to bomb the string, you just need to take the first occurrence, right? So as in the future you don't know like what you will get, and suppose the initial occurrences should be removed earlier, later one can be taken. So that's a simple greedy approach, right? And for this you can just maintain a stack, and the code is pretty simple, right? So you just maintain a stack, you just keep you take the input and then just keep pushing the elements in the stack until unless it's a B. If the element is a B, check whether the stack is empty or not. If the stack is not empty, just pop that element. Why? Because like even if the stack contains let's say B only, then again if you get a B, they should be nullified, okay? Or if the stack contains A and you get a B, right, then also this forms AB and they should be nullified, okay? So just remove the elements when you see a B at that time when the stack is not empty. Suppose like the first element you get B, right, then you cannot obviously pop, then you need to push this element to the stack, okay, because that's the first element, right? So just this condition handles that, and then basically after the end of the loop you just output the size of stack, because that elements will be left and that's the minimum requirement, right? That's the minimum you can go, okay, thinking greedily. Okay, so yeah, this was it, and this code was pretty simple as well. But if you have any doubts, do let me know in the comment section below. And yes, I know I did very poor in the contest, in the few contests, so please don't bomb me for that. And yeah, let's see what happens. Okay, okay, thank you, happy coding.